This next video is on pH indicators and buffers, and so this will be for not Tuesday, but Wednesday. So watch the video and complete the slides to follow. So pH, it measures the amount of hydronium ions in solution. So if a pH is between 1 and 6, it's acidic. If it's 7, it's neutral. And then if it's between 8 and 14, it's basic or alkaline. This shows the pH scale with some different colors and then some examples. So it goes from 0 to 14, battery acid being at a 0, stomach acid, so the acid in your stomach is actually very similar to, it is hydrochloric acid, has a pH of 1. So same pH as hydrochloric acid that we would use in the classroom. And then lemon juice, vinegar are going to be around a 2. And then towards the basic side of things, we have liquid drain cleaner at a 14, bleach, oven cleaner, soapy water is actually going to be more basic. And then obviously, your water, pure water, is going to be a 7. For pH calculations, to calculate, you will use these two equations. So we have pH equals the negative log of the concentration of hydronium ion. So if I have brackets, that's these little things, they're not parentheses, your brackets. That means concentration. So you will be given a concentration, which means you'll be given a molarity. So to find pH, negative log, and then the H3O plus concentration. To find the concentration of hydronium, we'll take 10 and we'll raise it to the power of the negative pH. So those are the two equations we're going to use. And then this shows you where they are on your phone. And then this one shows you those buttons on a Texas Instruments calculator. To calculate pH, we're going to use these two equations, our negative log of the hydronium concentration, and then to find that hydronium concentration, 10 raised to the power of the negative pH. So to find the pH of a solution that has a hydronium concentration, so brackets mean concentration, of 2.1 times 10 to the negative third molar. So molarity. So pH is just going to equal the negative log of that concentration, 2.1 times 10 to the negative third. pH does not have a unit, so it's just going to be a number. In my calculator, I'm going to type my negative, hit the log, and then put in my 2.1. If you remember that times 10, where we put the E and then my negative 3, close out my parentheses, and I get my answer. So my pH is going to be around 2.68. Okay, round to that second decimal place. To find the hydronium concentration, so we'll skip down to number 3 here. What is the hydronium concentration of a solution with a pH of 11.2? H3O plus is going to equal 10, and it's going to go to the power of that negative pH, so my negative 11.2. So on my calculator, I'm going to put in 10, raise it negative 11.2. So I'm going to use that little caret key, and then I'll get a concentration. And we get 6.31. And then remember E, you can leave it E or you can do times 10. And then this does have a unit. This is a molarity. And that's how you solve for pH and the hydronium concentration. Next up, we have indicators and buffers. So we'll start with indicators. These are going to specify the degree of acidity or basicity through characteristic color changes, basically telling you how acidic or basic something is. So different indicators we use are phenolphthalein, and that will indicate things that have a pH range of 8.3 to 10, and so that color changes colorless to pink as shown in that picture. Bromothymol blue has an indicator range of 6 to 7.6, and it will go from blue to yellow. And then methyl red is going to be more on the acidic side, so 4.4 to 6.2, and it'll go red to yellow. Methyl orange also has the same color change, and the pH range of that methyl orange is going to be if we have something between 3.1 and 4.4. So on the acidic side of that pH scale. Another indicator we might use, or you might use, is blue litmus or red litmus, as well as the universal indicator. So the universal indicator can indicate any pH. So all our different colors, this is what's used on that pH paper. So if you've ever, checked the pH of a pool, you've used pH paper, you've used the universal indicator. With buffers, so pH buffer, this resists changes in pH when we add acids or bases to it. So things we might use buffers for, like an antacid, is a buffer. So your Tums, Rolaids. This is very important for us as humans, so a bicarbonate buffer might be used if we have alkalosis or acidosis, and so your blood maintains this pH between 7.35 and 7.45. And the great thing is that the human body does this on its own, but occasionally we can have certain things happen, like respiratory acidosis. So you are going to be hypoventilating, and what that means is basically you're exhaling less than you inhale, and so that makes your blood too acidic. And so your lungs can't remove enough CO2 from the blood. So we increase that concentration of carbon dioxide, which then causes that blood's pH to decrease. For alkalosis, we're hyperventilating, so we're exhaling more than you inhale, and that causes the CO2 concentration to decrease. So your blood is going to become too basic, so the pH is going to be higher. And so your lungs are removing too much CO2 from the blood. And that is all I have left. And that is acids and bases for the week. This is your notes.